Today we are recording a final exam review over Chapter 6 and Chapter 7. This will cover questions 1 through 9 on the final exam review sheet as well as the final exam. Chapter 6, the first type of questions that we have, and what I've done before I go over this, each sentence at the top of each slide is the exact directions that you will be given on your final exam. So there should be no surprise there on what to expect. Those are the exact instructions given on the final exam. What they say is solve the inequality and graph the solution. So in order to solve this inequality, I've got to know what x is going to be equal to. But I do not have an equal sign in this problem. I have an inequality sign. So I need to know a general information about x. I need to know if x is going to be less than this number or greater than this number or what it's going to be. So what I do is I solve it exactly like I would a regular problem. So what I do is I just start off by adding 7 to both sides. Negative 3x is less than 9. Now, in order to solve for x, I'm going to divide by negative 3. Anytime you divide or multiply by a negative number on an inequality, you have to flip the sign. Does everybody remember that? We have to flip the sign. So it was less than, so now it's going to be x is greater than. 9 divided by negative 3 is negative 3. So I know that x has to be greater than negative 3, so any number larger. And step 2 of this problem is they want me to graph it. Now, I'm not talking about x and y axis, graph a line. It's just a number line, okay? So we take and we draw a number line on our page. Got negative 4, negative 3, negative 2, negative 1, and 0. Okay, now remember, whenever you graph on a number line, you have 2 types of circles. You either have an open circle or a closed circle. And what it means is the open circle is used whenever you have a less than or a greater than sign. The closed circle is used whenever you have a less than or equal to, greater than or equal to sign. So, Noah, what kind of circle would I use? Open circle. And where is that open circle going to be located? Over the negative 3, exactly. My circle is always located over the number that I have found that x is either greater than or less than. Now, I know that x is greater than negative 3, so I need to look for all the numbers that are bigger than negative 3, and they are going this way, so I shade to the right of my number line. Okay, that's all you've got to do to graph. On your final exam, each of these answers would be worth 1 point. So the fact that you got what x is greater than or less than is 1 point. The fact that you knew how to graph it is worth 1 point. Okay, there's 50 questions on the final exam. Now, the next type of problem, I actually did not give you one like this on your final exam review sheet, but there is one like it on your final exam. So that's why I've included it. I want everyone to pay close attention to this one. We've got x is greater than or equal to x plus 4 is greater than 3. This is what we called a compound inequality, and we have gone over these before. We did them in Chapter 6, and I still need to find out what x is going to be greater than or less than, okay? And I need to do this a certain way because I look at this problem right here, and I see that x is in the middle of my equation, or it's not equation, I'm sorry, my inequality. This does not mean, this is what I have so many people do, as they sit here and they go, okay, subtract 8, now I have x plus 4 is greater than negative 5. Now I can solve it. No, a compound inequality has got to stay exactly like it is, okay? It has to have the x right here in the middle. That's what makes it a compound inequality. The fact that it has an inequality at the beginning and an inequality at the end. So I've got to figure out, if x has got to stay in the middle, what do I need to move? The 4. So I just subtract 4. Whenever I subtract 4, I've got to subtract it from the front and the back. Now I've got 4 is greater than or equal to x is greater than -1. Now this is my final answer, because look, x is by itself in the middle. That's exactly what I want with a compound inequality. Okay, now I need to graph this. Anytime we have a compound inequality, you can always bank on this. I'm going to put the appropriate circle over each number, so I'm going to have a what kind of circle over 4? Closed. And a what kind of circle over -1? Open. X is always going to be everything in between those two numbers. So I always know to shade connecting the dots, basically. All right, so I'm going to start with -2, -1, 0, 1, 2, 3. I'm going to need to make this a little bit longer. 4, we'll put a 5 right there. Okay? So we already said I need a closed circle over the 4 because remember, it's greater than or equal to. And I need an open circle over the -1. Because it's a compound, I know that x is going to be equal to everything in between these numbers. So I just shade in between and connect the dots. Okay, that's exactly how we would do a compound inequality. Oops, I'm sorry, I went one too far. Okay, mean, median, and mode. Okay, what I've got to do is I've got to find these 3 pieces to this data. Okay, the mean. What does the mean mean? Average. The average. How do I find the average of these numbers, Tristan? Exactly. Add all the numbers up and divide by how many numbers I have. Now, if you have a calculator, you're probably going to want to use it on this part. The median. Before we even start to work it out, let's define what everything is. What is the median of the data? Who remembers? Sarah? The one right in the middle. Now, can I look and I say, okay, the median of my data is going to be 1. No. What do I need to do to that data first? Put it in order from smallest to biggest. Then I can find the middle. Okay? What is the mode of my data? The number that is listed the most. Very good. All right, so let's find our mean first. Someone add all of these numbers up and tell me what you get. Trent?
4.1 repeating.
Did you add all the numbers up?
Yeah.
Okay. What did you add? All right, Dexter, what are my numbers? No. Jalen? 45, correct. All right, add all these up. 8 plus 3 plus 2 plus 8 plus 1 plus 4, so on and so forth. I get 45. Now, count how many numbers I have. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have to divide 45 by 9. What's 45 divided by 9? 5. So my mean is 5. All right. Now I need to find my median. But before I can find my median, I have to order these numbers from smallest to biggest. So my smallest number is 1. Second number is 2. I like to cross them out of the original data because I'll get mixed up if I don't. Third number is 3. Then I have 4. Then 5. Then 6. Then 8. 8. And 8. All right, so what I like to do now is I just count from the outside in.
Does it matter where you start?
Yes. Oh, no. You can start either at the front or the back. Okay? So my median is 5. It's nice on this set of data because I got one number that's in the middle. What would have happened if I would have had two numbers that were in the middle? Tristan? You add them together and then divide by 2. So like if I had two numbers that were 5 and 6, I would add those together and get 11 and then divide that by 2, which would be 5.5. And you would leave it as a decimal, okay? You don't want to round to the nearest whole number. You leave it as a decimal. All right, and lastly, what would my mode be? 8, because I know that 8 is listed the most times. Now, can I have more than one mode? Yes. If I've got, let's say I had 6 and it was listed 3 times, that would also be my mode. So it would be 8 and 6. All right? Okay, the next type of problem that we have in Chapter 6 is the instructions say, is the ordered pair a solution of the inequality? Show your proof. All that means show your proof is you have to show work. I know most of you can look at this first problem and go 2 plus 3 is greater than, yep, yes, that is a solution. Okay, that is wonderful, but you still have to show me your work. So what they want me to do is they want me to take this ordered pair, which I always know is x comma y, plug it in and say, will it be a solution? So I say 2 plus 3 is greater than or equal to 5. 2 plus 3 is 5. Is 5 greater than or equal to 5? Yes, it is, because the reason why I can say yes is because it has that or equal to sign. All right, let's do the same thing for the second one. Again, showing all work. 2 times 2 plus 4 times 4 is less than or equal to 10. 2 times 2 is 4. 4 times 4 is 16, is less than or equal to 10. Add them together and I get 20 is less than or equal to 10. Is this a solution? No, it is not, because 20 is not less than, nor is it equal to 10. Okay, so now we move on to Chapter 7. Chapter 7, the first set of directions says, is the ordered pair a solution of the system of linear equations? Now, if you remember what we just did on the last slide from Chapter 6, I had an ordered pair, I plugged it in and said yes or no to the inequality, okay? And these are actually, I accidentally wrote the word equation here. These are inequalities instead, so because they do not have equal signs in them. So it should be inequality there, okay? Either way, what this means is these two inequalities are a system. So if this one ordered pair is not a solution to both of them, it's not a solution at all. So my answer would be no. Now, if I can plug in that ordered pair to both of them and it's yes, then my answer is going to be yes, it is a solution, okay? So let's try that. So 5 and 5, I know this is x and this is y. So I say 5 plus 5 is greater than or equal to 10. 10 is greater than or equal to 10. This one checks out. So I put a little check mark by it because I know, all right, I'm going to move on to the next one. 3 times 5 plus 4 times 5 is greater than 25. 3 times 5 is 15. 4 times 5 is 20. It's greater than 25. 35 is greater than 25. Does this one check out? Yes. Yes, it does. So I know since it is a solution to both, my answer is yes. Okay, let's try the next one. 2 times 2 plus 3 times 4 is greater than or equal to 14. 2 times 2 is 4. 3 times 4 is 12. Oops. 4 plus 12 is 16. Is greater than or equal to 14. Does that one check out? Yes, it does. All right, let's try the next one. 6 times 2 plus 2 times 4 is less than 24. 6 times 2 is 12. 2 times 4 is 8. Then I get 20 is less than 24. Does that one check out? Yes, it does. So actually, both of these are going to be solutions. Now, if you get an answer, let's say that this one was like 25. Let's say I ended up with 25. So it would be 25 is less than 24. That would be no. So my entire answer would be no. When it's a solution to one and not the other, then your answer is no. Okay? Okay, so the last questions in Chapter 7, and there's actually only 2 of these on your final exam review sheet and the final exam. Okay, but I put 3 on here because they represent 3 different stages that you would do. Okay, I didn't want to show you one without showing you first how to do it. All right, so solve each linear system with the method of your choice. Now, if you remember, there were 3 different methods that we could use to solve this system of linear equations. Now, because what I'm looking for is I'm looking for that magical ordered pair, or what x equals and what y equals, that I can plug in for both of these equations and get, yes, it is a solution. So there's 3 different types of ways I can do that. The first way is to graph them. So what I would have to do is I'd have to put each equation in y equals mx plus b form, get out my graph paper, graph the lines, and wherever those 2 lines crossed, that is the solution to both equations. Now, graphing, I would say, is a little bit tricky when you don't have an exact graph with a ruler. Because if you accidentally draw your line a little crooked, or maybe you've drawn your graph on your page and your numbers aren't exactly spaced out evenly, then you may not get the right answer. It may look like it crosses at a certain ordered pair, but it really doesn't because your graph is not perfectly. So I would say if you're going to do graphing, make sure you have a perfect graph to do it on, which you're not going to have one of those on your final exam or the review sheet. So I would skip that part. Okay? Second option is substitution. Substitution means I get one variable by itself. So if you notice in these equations, I always have an x and a y. So substitution would mean I get something by itself. Like let's say I got y by itself. So I would have, I'm just going to make this up. I think it would be like negative 1x plus 2. Okay? And then I know what y equals. It equals negative 1x plus 2. So what I would do is I would plug that in for y in my equation, and I would solve and find x. Once I found x, I could use that, and I would plug it in and solve to find y. Okay? That's substitution. Then we have elimination. Elimination means I can take these problems and make it like a ginormous addition problem. I am looking for terms that will cancel out. Whatever terms cancel out, like right here, 3y minus 3y, that gives me 0. That means those terms cancel out, and I can add them together and find out what x equals. On this problem that we have here, I would say elimination would be the easiest method to do. Because if I look, I've already got my 2 terms that will eliminate. 3 and 3y. So I cancel them out, and then all I do is add the other terms I have together. 5x equals 10. All I need to do now is solve for x. So I divide by 5, and I get x is equal to 2. That's one of my answers. Now I need to plug that back in, and I need to solve for y. So I can plug this in to either one of these equations. It does not matter. You will get the same answer no matter which equation you plug it in. So I'm going to plug it in the first one. 3 times 2, now that I know what x is, I plug it in, plus 3y equals 6. 3 times 2 is 6, plus 3y equals 6. Then I subtract 6. And I get 3y equals 0. Then I divide by 3, and I get y is equal to 0. Then I know exactly what y equals and exactly what x equals. That is elimination. Okay? Okay, so what I look at is I've got my next problem now. And I want to figure out, okay, there's 3 different ways that I can do. Graphing is probably out because I don't have an exact graph to graph it on. I don't have my ruler ready, so I'm just going to leave it, and I'm not going to do graphing. But I've got substitution and elimination. The first way I'm going to show you is by substitution. Then I'm going to go back and show you how to do it with elimination, so you're clear on both methods, okay? The first method is substitution. What substitution means is I need to get one variable by itself. It does not matter which variable. It can be a y, it can be an x, and it can be in the first equation or the second equation. So I look and I say, okay, this x right here looks to be like it's going to be the easiest to get by itself, because all I need to do is add 6y to both sides. So that's exactly what I do. And I get x equals 6y minus 6. Now, I know what x equals. 6y minus 6. So what I do is I go to the other equation, not the one I just got what x equals, but this one right here. And instead of plugging in an exact number for x, I can plug in 6y minus 6. So I write this 2 times. Instead of plugging in x, I write 6y minus 6. Then I just write the rest of the problem. Plus 3y equals 3. And I solve for y. So right now I need to do distributive property. 12y minus 12 plus 3y equals 3. Then I combine like terms and I get 15y minus 12 equals 3. Add 12 to both sides. 15y equals 15. Divide. And I get y is equal to 1. Now I have what y equals, but I still need to find out what x equals. So what I can do is I can just go to this equation right here where I got x by itself and plug it in and find exactly what it equals. So I say x equals 6 times 1 minus 6. 6 times 1 is 6 minus 6. 6 minus 6 is 0. So now I know x equals 0 and y equals 1. That's how you can do it with substitution. Now, I'm going to clear all this off and show you how to do it with elimination. All right, we have our problem here. And I look, in this last problem, okay, I was able to eliminate something right off the bat, because if I were to add it together, it equals 0. But I look here, okay, and I don't have anything that will eliminate automatically. But I say, okay, I've already got a positive and a negative here, which is what I need to start out with. All right? And how do I make them eliminate? What could I do to 3 to make it eliminate with negative 6? Multiply it by 2. So if I multiply this one term by 2, I've got to multiply every other term in that equation by 2. So I'm just going to rewrite it right below it. 4x plus 6y equals 6. Now I can use elimination. These two terms will eliminate. I know there's a 1 right there, so I go to add and I get 5x equals 0. Divide by 5, and x is equal to 0. Now, I can choose any of these 3 equations. I can choose this one, or this one, and plug x back in and find out what y equals. Okay, so that's exactly what I'm going to do. I'm going to use the second one that we have. So I'm going to do 1 times 0 minus 6y equals negative 6. What does 1 times 0 equal? 0. So I can basically just cancel that out. And I get negative 6y is equal to negative 6. Divide by negative 6. And what does y equal? Now, if you notice, we got the exact same answer that we did when we used substitution. It does not matter what method you use, as long as you do it correctly, you will get the same answers for each method. Okay, the last problem that we have is a little bit different because look at each of these equations. I have 5y equals 25 and 2x plus 3y equals 45. If the whole point of this is to find what x equals and to find what y equals, can I find what y equals very quickly?
Yes.
Yeah, because I have 5y equals 25. All I need to do is do what to solve for y?
Divided by 5.
Divide by 5, which is exactly what I do. And what does y equal?
5.
5. That was easy. Okay, now in order to solve for x, I plug it back in. 2x plus 3 times 5 equals 45. 3 times 5 is 15. Then I subtract 15. And I get 2x is equal to 30. Divide by 2 and I get x is equal to 15. So I know exactly what x equals and exactly what y equals. Okay, those are the 3 types of methods you could use: graphing, substitution, and elimination.